What's up everyone, welcome back. It's the first week of March and the research labs have been absolutely cooking. This week alone we had papers from DeepSeek, Harvard, Microsoft, Nvidia, ByteDance, Skywork AI, NYU, and so much more. I went through Hugging Face training, different publications, and I pulled this list of 10 papers that genuinely matter right now. The ones that are moving the frontier, not just tweaking benchmarks. No filler, let's get into it. Agents of Chaos from Harvard University and Northeastern University. It was released on 23rd of February. And starting with a paper that should be required reading for anyone building or deploying AI agents. These researchers took autonomous LLM agents and dropped them into real-world interactive environments to see what happens. When they found is alarming, emergent vulnerabilities that nobody explicitly programmed in. We are talking unauthorized compliance, agents doing things they weren't supposed to, sensitive data leakage, resource exhaustion, identity spoofing, and unsafe practices spreading from one agent to another. The key word here is emergent. These aren't bugs you can patch. They arise from the combination of LLM capabilities, autonomy, and tool use interacted in ways nobody anticipated, and we push agents into production in 2026. This paper is the hard warning everyone needs to read before deployment. It already has over 2,000 views in days, which is amazing. Next, infrastructure, and this one comes from a collaboration between Peking University, Tsinghua, and DeepSeek-AI. I hope I pronounced it correctly. DualPath solves one of the most annoying bottlenecks in Agentic LLM inference, storage bandwidth. When agents run long tasks with massive KV caches, loading all the data from storage becomes the choke point, not the GPU. DualPath introduces a DualPath KV cache loading mechanisms that distribute the load across storage bandwidth. The result is, we can find it, as it was written here, 1.87 faster job completion for offline inference, and there is a 2.25 more agents per second for online serving. Those results are quite great, and this is the kind of infrastructure paper that doesn't get the Twitter hype it deserves, but if you're running any kind of production agentic system, this directly impacts your costs and latency. Okay, let's shift to multimodal generation. Skyril's V4 from Skywork AI is a unified foundation model that does video generation, audio generation, inpainting, and editing all at once from diverse inputs. The word unified is doing a lot of work here. Most video models are siloed, one model for generation, another for audio, another for editing. Skyril's V4 handles all of it in one shot with synchronized audio across high resolution, long duration content, and the benchmark back it up. It ranked, let me see if I can pull them off here. It ranked third on a public video arena leaderboard and scored the highest overall on human evaluation against leading commercial systems, including the big closed models. Skywork AI is a name to watch. This is a serious result. Paper 4 is about robots and it's from ByteDance Seed. The core problem with vision language action models for robotics, you have a trade-off. I've discussed this in my previous video as well. Efficient future representations are too coarse for fine-grained control. Detailed representations are too heavy to run in real time. ByteDance World Guidance framework breaks that trade-off by using a compact condition space derived from future observations to guide action generation. Instead of giving the robot the full predicted frame, real-world results are 69.4% average success rate on Google robot simulation tasks, plus robust generalization to out-of-distribution scenarios it had never seen in training. For a field where 50% success in real environment is often considered good. This is actually meaningful. Good. This one is early infused, but the GitHub stars tell you the community sees something here. dLLMs, an open source framework for diffusion language models. The idea behind is simple. Rather than generating text autoregressively, token by token, diffusion models generate the whole sequence at once, iteratively refining it. The problem has always been that it's hard to reproduce or build on these models because everyone uses different training setups. dLLM standardizes everything. It gives you unified recipes to convert existing encoder-only or autoregressive models into diffusion LMs with accessible compute. The results show improved reasoning capabilities and competitive performance from smaller converted models. It has around 2000 GitHub stars in just days. That's the open source community saying we've been waiting for this. World models are one of the hottest topics in 2026, and Solaris from NYU just pushed the boundary in genuinely novel direction. It's the first action conditioned video world model that simulates multi-agent, multi-view interactions built in Minecraft. Why does multi-agent matter? Every world model before this handles a single agent's perspective. Solaris can simulate what multiple coordinated agents see simultaneously. Consistent views across all of them over long horizons, and it hits 71.4 VLM accuracy on view consistency and 20.8 on building tasks, outperforming all baselines. Minecraft might sound like a toy domain, but it's actually one of the hardest environments for world models. Complex physics, partial observability, and open-ended tasks. This is a real technical achievement that will matter for robotics and multi-agent AI. From Microsoft Research, we have AMPO squared, and the numbers in this one are wild. The problem they are solving, LLM agents are bad at exploration and terrible at generalizing to tasks they haven't seen before. AMPO squared combines parametric policy optimization with non-parametric memory updates in a hybrid reinforcement learning framework. The agent can both update its weights and store explicit memories, and it uses both together. Results on Science World: 128.6% improvement in average return over the GRPO baseline. On out of distribution, 136 better adaptability with limited trials. The underlying framework, Agent Lightning on GitHub, already has over 15,000 stars. Microsoft is clearly betting hard on this direction for the future of Agentic AI. This one is more theoretical but has major long-term implications. Google Research published a paper on memory caching, a technique that lets recurrent neural networks grow their effective memory capacity with sequence length rather than staying fixed. This has been the fundamental limitation of RNNs forever. They have a fixed hidden state, so they can't handle long contexts no matter how long you train them. Transformers won because they have quadratic attention over the full sequence, but transformers are expensive at inference time. Memory caching changes the equations. RNNs with MC can now match transformers on long context and recall intensive benchmarks while keeping sub-quadratic compute. Google is quietly signaling that RNN family architectures aren't dead. They might be the future of efficient long context inference. 3D construction is one of those problems that sound solved but really isn't at scale. VGG3 from Toronto and NVIDIA makes one of the hardest versions of the problem, processing 1000 plus images simultaneously. The trick, they distill a transformer's variable length scene representation into a fixed sized MLP at test time, reducing the computational complexity from quadratic ON squared to linear ON. The result is an 11.6 speedup improvement over the quadratic baseline, processing 1000 images in 1 run minute. For applications like autonomous driving, robotics, and large-scale mapping, where you need to rebuild 3D scenes from the hundreds of camera frames in real time, this is a practical breakthrough, not just a benchmark number. Closing out with something I think is underrated, SymTorch from Cambridge, an open source PyTorch library for symbolic distillation of neural networks. The idea, neural networks are black boxes. SymTorch lets you take a trained neural network or specific components inside it and replace them with explicit mathematical expressions, actual symbolic equations that you can read, verify, and reason about. The practical results are already impressive. 8.3% boost in LLM inference, throughput from distilling certain components, plus successful discovery of physical laws from graph neural networks and PD solutions from physics-informed networks. The long-term implication is huge. If we can distill neural networks behavior into interpretable math, we can get a path toward AI systems that are actually explainable. Not just here is the attention map, but here is the actual equation the model learned. Alright, stepping back, what does this week tell us? First, agents are growing up fast, and so are attack surfaces. Agents of Chaos from Harvard and EMPO from Microsoft are on the opposite ends of the same problem, one showing what goes wrong when agents have autonomy, one showing how to make them smarter. Both are essential reading. Second, the infrastructure layer is getting serious. DualPath from DeepSeek research group proves that the bottleneck is no longer the model. It's moving data around. The teams winning in production are the ones solving these boring infrastructure problems. Third, world models are maturing beyond single agents. Solaris running multi-agent consistent with world model in Minecraft. WOG from ByteDance achieving 69% robot success in real environments. This is no longer demos, it's getting real. Fourth, there is a quiet push toward interpretable AI. SymTorch and Google's memory caching work are both signals that this field is starting to ask, how does this actually work, rather than just how high can we score. The paper I would bet on being cited the most in a year, I would say the first one, definitely. The safety implications of emergent agent vulnerabilities are going to be a defining conversation of 2026. And if you want links to any of these, they are all in the description. Subscribe if you want this every week. See you in the next one.